Assalamualaikum and hello everyone. This week we are going to learn a new chapter, Chapter 9, Quantization of Light. The first subtopic, 9.1, Planck's Quantum Theory. Okay, so before I can talk about this theory, so let's go back to the chapter 8. So in chapter 8, we have learned that light behaves as wave. This one I have mentioned before, that light behave as wave. So you know that this is the shape of wave, where if we have light coming from a source, let's say this one is the flashlight. So contohnya ni adalah flashlight lah. And then there is light coming from this flashlight. And then according to Huygens principle, if we meet obstacle for single slit, what happen is they can bend. The light will bend and then causes a diffraction. So this one causes a diffraction. This one we call this as a wave as well. Sama lah macam this one. Or if we have double slit, it will cause interference. So this one is the first theory that scientists come up with. We call this as classical theory, di mana energy is radiated in continuous form, because light dia continuous macam ni, ataupun macam ni, because this light has energy. So that's why classical theory cakap energy is radiated in continuous form. So kalau dia continuous form, energy is independent of frequency, maksudnya dia tidak bergantung kepada frekuensi. So ni adalah classical theory. And then years and years after that, scientists come up with a new theory, a modern theory. We call this as Planck's quantum theory, di mana dia cakap dekat sini, energy is radiated in discrete packets of energy ataupun quantized. So now, scientists dia berjaya buktikan di mana if we have a light here, if we have light coming from a flashlight, and then this light actually it brings energy, dia radiates energy, tapi energy ni is now in discrete packet, bukan lagi continuous. In discrete packets bermaksud dia macam ni, dia dalam packet sudah. Okay, so this is the light is now radiates in discrete packet, dan discrete packet ni kita panggil sebagai photon. So as you can see here, we have wave adalah dekat dalam, and then di dalam packet. So now we can say that light behaves as wave and particle. So dia behave as wave and particle. Wave ni di dalam packet, because setiap packet ni kita panggil dia sebagai particle. So now light behaves as wave and particle. This is the modern theory. Yang scientist yang come up with this theory adalah Planck ni lah. That's why kita namakan dia sebagai Planck quantum theory, di mana energy is dependent on frequency. So setiap packet ni akan ada energy yang depends kepada frekuensi. So now kita baca dulu lah dekat sini. According to the theory, electromagnetic radiation. So electromagnetic radiation ni adalah radiation daripada the light, can only be released in discrete packets. This is what we call as discrete packets or quanta ataupun quanta. And singular dia adalah quantum. So singular packet ni kita panggil dia sebagai quantum. So remember, each of this packet we call them as photon. So since energy is dependent on frequency, so the formula that we are going to use is energy is equal to H, di mana H adalah the Planck constant, which is equal to 6.63 exponent negative 34 joule second. So it's a very small value, negative 34 joule second, but there is still a value. And then this one, F is just frequency, or it is equal to h, still the Planck constant, times with c. C is the speed of light. The speed of light, which is constant, equal to 3 exponent 8 meter per second divided by the wavelength of the light. So let's say if we use, macam ni kan, we use yellow light. So there is a wavelength of this light. If we use a violet light, we have a smaller wavelength. If we use a red light, we have a larger wavelength. So, ni adalah formula yang kita akan gunakan dalam subtopik ni. Okay, so we know that energy, SI unit dia adalah joule. So, this one yang kita belajar lah sebelum ni. But, dalam chapter ni, we always leave energy in a new unit. Unit yang kita guna adalah electron volt ataupun EV, di mana 1 electron volt bersamaan dengan 1.6 eksponen negatif 19 joule. So if we want to convert daripada joule kepada electron volt, okay, kita kena bahagi 1.6 eksponen negatif 19. So if we want to convert daripada electron volt kepada joule, kita kena darab lah. It's as simple as that. And then remember, if we are using this formula, kita punya jawapan akan dalam joule dahulu, because this Planck constant adalah dalam joule second. And frequency macam biasalah, unit dia adalah dalam hertz ataupun per second. Okay, so kita akan tengok example in the next video. Okay, that's all for 9.1. Thank you.